Good day, students. On this group, we're going to be going over 3 questions and how to find trig functions using the basic identities, okay? So before we go ahead and start taking a look at the examples, let's consider some identities that we're going to be using in this problem. So um, the reciprocal identities are as follows. Let's write it down, reciprocal identities. And we're going to be using SOHCAHTOA for our setup here, okay? So we'll remember SOHCAHTOA. Let's write that on the side. SOHCAHTOA. All right, so what does this tell us? We know that we know that sine theta equals opposite of a hypotenuse. If sine is opposite of a hypotenuse, that implies that its reciprocal cosecant theta, is hypotenuse over opposite, okay? And then cosine from cosine theta is adjacent over hypotenuse. That tells us that, or that implies that secant theta equals hypotenuse over adjacent, okay? And we know that tan theta from TOA equals opposite over adjacent, and that tells me that this reciprocal cotangent theta is adjacent over opposite. All right, so there we have it. Okay, so if we want to find, if we're missing any of these components, let's say we have a O, we're missing an H, and let's say we have 2 out of the 3 sides of a triangle, and we need to find the third side. All we just simply do is use the Pythagorean Theorem for right triangles. So let's go ahead and sketch that. We're also going to be using this Pythagorean identity right here. So let's say this is the angle. It doesn't really matter where the angle is. Let's call this theta. And this is theta. This is the opposite, because it's opposite the angle. This is the hypotenuse, because it's the longest side opposite 90 degrees, and this is the adjacent. So from the Pythagorean theorem, we know that a squared plus o squared equals h squared. Okay? So this is another formula we're going to be using. And last but not the least, we're also going to be using our coordinate system, and all students take calculus to figure out the sine of the angle that we're looking for. Okay? So there goes our coordinate system. This is 0 degrees. This is pi over 2, or 90. This is pi, or 180 degrees. And down here is 3 pi over 2, or 370. And then going full circle, we have 2 pi, or 360 degrees. So this is 3 pi over 2, and this is 2 pi. Okay. Now we know that all students take calculus starting from quadrant 1. Now what does this mean? A basically means that all the trig functions, all 6 of them are positive. So it tells me that sine and cosecant are positive. Cosine and its reciprocal secant are positive. And tan and its reciprocal cotangent are positive. Note that they always go in pairs, okay? S means that only sine and its reciprocal cosecant are positive here, okay? And this one, tan, means that only tan and its reciprocal cotangent, remember we talked about the reciprocal relatives here, tan and cotangent are positive here. And C means only cosine and its reciprocal secant are positive. Okay, everything else is negative. So this is what it means. So we have an angle in any of these quadrants that do not match, and that basically means that that angle is negative, or that trig function is negative. All right, so let's go ahead and take a look at some examples. Number 1, find sine pi if, actually I meant to say sine theta. Find sine theta if tan theta equals 7 over 3 and pi over 2 is less than theta, and theta is less than pi. Okay? Alright, so this is what we're supposed to find. Now, is this a reciprocal connection? If I reciprocate tan, I get cotangent, so I cannot solve this answer by reciprocation. I have to use the Pythagorean theorem to figure this out, okay? So let's see what we have. We know that we have tan theta is 7/3. If you look at our setup up here, tan is opposite of adjacent, so I can conclude that the numerator is the opposite and the denominator is the adjacent, okay? All right, so what are we looking for? We're looking for sine theta. Sine theta from so is opposite of a hypotenuse. But I know that my opposite is 7 from here, and my adjacent is 3. But what on earth is my hypotenuse? I do not know. So anytime you have two of the sides of a triangle, of a right triangle, you want to find a third side, you use the Pythagorean theorem, okay? So we're going to use the formula a squared plus o squared equals h squared that we talked about earlier here, the Pythagorean identity, and then we're going to plug in what we know and find what we need, okay? So a is 3 squared plus 7 squared, 7 squared equals h squared, okay? All right, so let's do this. We're going to have 3 squared is 9 plus 7 squared is 49 equals h squared. H squared equals 58. And then to get h by itself, we'll take the square root of both sides. And then we're going to have h, the hypotenuse, is either positive plus or minus the square root of 58. Okay, so can 58 be reduced? Let's go ahead and check it on the side. Square root of 58, let's break it down. This is even, so I can take out a 2. 2 times 29. 29 is prime, so this cannot be reduced because there aren't any repetitions in the factors. All right, so now we now know what sine theta is. So sine theta is equal to the opposite, which is 7, over the hypotenuse plus or minus root 58. Okay, so we can't have a radical in the denominator, so we have to rationalize this. Root 58 top and bottom. So sine theta is positive plus or minus 7 root 58 over 58. So the question is sine positive or negative? That's the question. All right, so to answer this question, we have to consider the restrictions on theta. Theta is between pi over 2 and pi. All right, so let's go ahead and sketch that scenario. Make our coordinate systems with 4 quadrants. And then let's go ahead and label it. So we have 0, pi over 2, and pi. Theta is between pi over 2 and pi, so we're over here, quadrant 2. We know that all students take calculus. So S basically means that sine and cosecant are positive. So do we have a match here? Was what we're looking for match with any of these? Absolutely, we have a positive match right here for the sines. So sine is positive in this quadrant because it matches one of the functions that are positive, okay? So this basically means that sine theta is positive 7 root 58 over 58. And there goes our final answer, okay? All right, let's go ahead and try another example. Question 2. Find the exact value of tan theta if cotangent theta is equal to root 3 over 7 and 0 is less than theta and theta is less than 90 degrees. All right, so let's go ahead and find this one. All right, so what do we have in this case? We know that cotangent theta is root 3 over 7. Okay, so which is which? I know that from TOA that tan is opposite of adjacent. So since tan is opposite of adjacent, that tells me that tells me that cotangent is a reciprocal of that. So this is going to be adjacent over opposite. So this will be the adjacent, and this will be the opposite. Okay, adjacent over opposite. So what is tan then? You see in this case, tan theta is adjacent over opposite. I'm sorry, opposite over adjacent from TOA and secant TOA. So tan is opposite over adjacent. So the question is, can I just simply reciprocate, or do I have to use a trig, the Pythagorean identity? I don't have to use the Pythagorean theorem here because I have everything I need. I have the opposite, which is 7, and I have the adjacent, which is root 3. Okay, so I'm good to go. So in this case, we have the opposite, which is 7 over root 3. Okay, we can have a radical in the denominator, so we rationalize the denominator, square root of 3 top and bottom, and then we have 7 root 3 over 3. Okay? Alright, notice there isn't any ambiguity here with the sign because we did not use the Pythagorean theorem. Anytime we use the Pythagorean theorem, there's always going to be that plus or minus situation, but we don't have that here. Alright, so there goes the value of tan. And the quadrants do not really matter because when you reciprocate, the sign doesn't change. Alright, so there goes your final answer. Okay, let's take a look at question number 3. So question 3, find the exact value of sine theta if secant theta is equal to 8 over 3 and pi is less than theta and theta is less than 3 pi over 2. Okay? Alright, now let's go ahead and see what we have. We have secant theta is 8 over 3, right? We know that secant is related to cosine. It's related to cosine, and cosine is adjacent of a hypotenuse, so this must be the reciprocal of that. So secant is hypotenuse over adjacent, the reciprocal of okay? Adjacent of a hypotenuse. We're looking for sine in this situation, sine theta. And so we know sine is opposite of a hypotenuse. Alright, we know that our hypotenuse is 8. We know that our adjacent is 3. But guess what? We do not know what our opposite is. So to figure this out, we're going to use our Pythagorean theorem, Pythagorean identity, a squared plus o squared equals h squared. So let's see. And I use this equation to find o, so we can know what sine is, okay? So a is 3 squared plus o squared equals 8 squared. Alright? So 3 squared is 9 plus o squared, 8 squared is 64. So we subtract 9 from both sides. Subtract 9, subtract 9. And then we're going to have o squared equals 55. Okay? So let's read both sides. To isolate o, you read the left and the right. Read this, read that. So we have o equals plus or minus the square root of 55. Okay, remember whenever you take the square root of a square, you have an absolute value situation, and you have to add the plus or minus, all right? So it looks like we have all we need to construct the sine. So let's go ahead and do that. So sine theta is going to be the opposite, which is plus or minus root 55 divided by the hypotenuse, which we knew before as 8. Okay? Now, we have an ambiguity here. Is sine positive or negative? So in order to do this, we need to consider the constraints on theta, okay? So what are the constraints on theta? Theta is between pi and 3 pi over 2, so we know that we're going to find sine, we're supposed to find sine when pi is less than theta and theta is less than 3 pi over 2. Okay, so what quadrant is that? That's the question, all right? Let's go ahead and sketch it. Four quadrants. Such are 4 quadrants. Now, let's label it. I have 0, pi over 2, uh, pi, 3 pi over 2. So our angle under consideration is, the quadrant under consideration is quadrant 3. Okay, we know that all students take calculus. So what does the T here mean? The T basically means that tan and its reciprocal cotangent are positive. Okay, so do we have a match here? We're looking for sine, but we have tan and cotangent as being the only positive trig functions in this quadrant. So guess what? Sine is negative in quadrant 3. All right, so our final answer, sine theta in this quadrant is negative root 55 over 8. Okay, so there you have it. Well, thanks so much for taking the time to watch this presentation. Feel free to subscribe to my channel by clicking up here. And please post a comment to let me know what you think about this clip. And if you like this video, you can always click like. More clips can be found on mathgoodserve.com. Thanks again and have a wonderful day.